Hello, science family. Today we are going to learn about valence electrons so that we can figure out what charge an atom will turn into when it becomes a cation or anion. Quick review, an anion is an atom that forms a negative charge, so it becomes an ion and is negative. And a cation is a positively charged ion. But let's look at how that actually happens. And to do that, we have to understand about valence electrons. So valence electrons are the outermost electrons. So in this picture, in this element germanium, there's a lot of electrons, but these four are the outermost electrons. So these four electrons are really the ones that touch the outside world, the outside environment. And because of that, it really affects the chemical properties of that atom. If you think about it, when we get deeper into chemical reactions, you're going to see that the outside electrons, the valence ones, are really what determine what charge an element can have, and from there it determines what it might bond with. Also, it might share electrons on the outside, and that can form a covalent bond, which again, we'll get into. So let's dig into how we figure out what valence electrons are and how many there are. So there's a simple trend for valence electrons. If you look on the periodic table, the tall columns actually form a very simple trend of 1, 2, 3, 4, 5, 6, 7, 8 valence electrons. So if you look at, for example, group 1 on your periodic table, that means it has 1 valence electron, 1 outermost electron. Group 2 has 2 valence outermost electrons. If you jump to group 16, you'll notice that it has 6 valence electrons. Just drop the teen, it's 6. Group 8, the last group, or 18 I should say, has 8 valence electrons. So if we blow that picture up a little bit, and you can see that on the periodic table, besides what we call the transition metals, the metals in between here that kind of vary, and you could just look that up if you had to, Google iron and how many valence electrons it has, etc. The outside columns, though, have a super easy trend. So if we look at what column they're in, that can tell us how many valence electrons there are. 8. So to figure out the charge that an atom gets when it becomes an ion, we have to know one thing. Atoms really want 8 valence electrons. When they have 8, they're more stable, they have more, or I should say less energy, so they're lower energy, they're much happier. So atoms really do want those 8 valence electrons. And what they're going to do is they'll either lose electrons so that outer energy level goes to 0, or they'll gain electrons to get those 8 valence electrons. Now you might be thinking, well, if they want 8, why would you lose and go to 0? And that's because if you lose all your outermost electrons, the valence electrons, you actually get rid of that outside energy level and you uncover a full shell of electrons that have 8 already. So whichever is easier to do, either lose or gain to either go to 0 or 8, that's what an atom is going to do in order to form an ionic charge. So for example, if an object has 3 valence electrons, it could either lose 3 or it could gain 5, either to go to 8 or to get to 0. Now, losing 3 is quicker than gaining 5. So losing 3 wins in this case. So whatever is quicker and easier, that's what an atom will do. So if you look at metals, which tend to be in group 1, group 2, and group 13, they have 1, 2, and 3 valence electrons. So they, because it's quicker to lose electrons and go to 0 than to gain 7, 6, or 5 electrons and go to 8, they're going to lose that electron, those electrons, to go to 0. Well, when you lose 1 electron, overall, the atom becomes a cation, +1. When you lose 2 electrons, overall, you become +2 cation. When you lose 3 electrons, overall, you become a +3 cation. All right, now the opposite happens with nonmetals, which are often found in group 15, 16, and 17. In fact, in group 15, you have 5 valence electrons. Group 16, you have 6. In group 17, you have 7. So it is quicker to gain electrons to get to 8. So that's why when you add 3 to group 15 ones, you now have 8 electrons total, and that gives you a -3 charge because you gained 3 negative electrons. If you're group 16, you have 6 valence electrons, and if you gain 2 more to get 8, you now have an overall charge of -2 because you gained 2 negatively charged electrons. And group 17, you only need one more electron to get to 8. So if you have one more electron, that is going to end up giving you a -1 charge because you have an extra negative electron. So you can start to see by gaining and losing electrons, you give the element a charge, and it either becomes a cation or an anion. Let's look at an example of something that's going to turn into a cation. Potassium, which is in group 1, means that it has one valence electron. So if it has one valence electron, it could either lose 1 and go to 0, or it could gain 7 to go to 8. Well, losing 1 is a lot quicker, so this is the way to go. If you lose 1 electron, you become positive in charge because you now have more protons than electrons. Don't forget, when potassium is neutral, it has the same number of protons and electrons. But when you now have 1 less electron, you now have more protons, which makes it positively charged. That's why potassium becomes a +1 charge. Now nitrogen, different story. Nitrogen is in group 15 on the periodic table. Check for yourself. That means it has 5 valence electrons, which means if it has 5 electrons, it'd rather gain 3 than lose 5. So if it gains 3 electrons to get 8, that means you have a -3 charge and it becomes an anion because you added 3 negatively charged electrons. And overall, nitrogen gets a 3- charge. If we try to practice, let's think about the element sulfur, all right? Sulfur ends up being in group 16. So if sulfur is in group 16, that means it has 6 valence electrons, okay? If it has 6 valence electrons, would it like to lose 6 or gain 2? It would gain 2. So if you gain 2 electrons, all right, that means you end up having an overall charge of -2. So that's why the sulfur anion becomes S2-. All right, so to answer the first question, it had 6 valence electrons. And to answer the second question, it ends up with a -2 charge. All right, let's look at calcium. Calcium ends up being in group 2. Well, if it's in group 2, that means it has 2 valence electrons. All right, answer the question. And 2 valence electrons, it's easier to lose 2 than gain 6. So if you lose 2 electrons, if you lose 2 negative charges, then you're going to end up with a 2+ overall charge because you now have more protons than electrons. So by losing 2 electrons, you get a +2 charge, and that's what calcium's cation charge is, +2. All right? Start thinking about it. If you're having trouble with losing electrons becomes positive and negative or gaining electrons becomes negative, remember that the charge of an atom or an ion is really the number of protons minus the number of electrons. So if you gain electrons, you're subtracting by a bigger number, and that makes it negative overall. If you lose electrons, you're subtracting from protons with a lower number, and that makes it positive. Again, it's important. Try to practice that and wrap your head around it, because knowing the charge an element forms will be really important, especially when we get into chemical reactions. All right, science family, thanks for watching, and best of luck.